So for question 29, I'm going to read the question, then I'm going to cheat and pause the video here. Which hydrogen has the smallest integration value? So integration, again, hydrogen NMR, I need to be looking at hydrogens. So I want to draw on all of my hydrogens. With the power of pause, we can show all of our hydrogens. Because this is a multiple choice question, and if we look at the structure, we have A through E, that's 5 answer choices, I can immediately eliminate, what is it, A, B, C, for those of you that don't think I know my alphabet, that's probably true. I'm going to eliminate D from the question, so now I've erased that. And now I'm going to go through and evaluate and compare. So if I take a look at HE, the far right of the structure, well, these hydrogens are all identical due to sigma bond rotation. So that means HE comes in with an integration value of 3 hydrogens. Okay? If I move to HC as the next one, okay, same deal, due to sigma bond rotations, both those hydrogens will be identical to each other, so HC comes in at a value of 2. If we move on to HB, running out of colors, HB, and we take a look at HB, we might say, well, there's only one hydrogen attached, so that's going to be fair game, except there is a line of symmetry running through here, through the aromatic ring, because you could go ahead and rotate those structures to line up, which then means that these two are identical to each other, which means HB comes in as 2. The other hydrogens across the way over here are not identical to HB because there's no line of symmetry here. That's a false line of symmetry because those two halves aren't equal to each other. Okay? And then we've got HA. Trying to look at HA, well, most people will go through and say, well, then there's 2 hydrogens because they're connected to the same carbon. This should immediately cause problems because while we could eliminate HE, having the most hydrogens here, we have 3 answers with 2 hydrogens. This means that we missed something when we went through and evaluated. And what we missed was that Mike talked about pi bonds in particular in the very first unit. And those pi bonds have an issue. That issue is that they cannot rotate. What does that mean? Okay, well, because of this, HA sees a hydrogen, H question mark sees the structure. The only way that H question mark can see that hydrogen is if I broke the pi bond. I'm not allowed to do that. There is no pi bond rotation. What does that mean? H question mark and HA are not identical. So we have to remember those structural features that we talked about back in the first unit. It's easy to forget them. Here's where it can come back and haunt you if you don't remember that. That means HA is not actually 2 hydrogens. HA is actually 1. There's your answer. Okay? So that's the answer to that one. A little bit longer than the others, but not too bad.